distances on the surface of Mars. These new rovers will act like mobile field geologists. This mission is actually very exciting compared to previous missions. For the first time, the rovers will be able to go much greater distances away from the lander, and for the first time we could also go to a hill on top of it and see what's over it. And so we would be able to cover a lot more different areas and see different geological features to try to get a better understanding of how Mars is evolving in those regions.
Prayson, what's the process of getting the rovers to Mars?
Well, Tonya, the rovers will be launched on Delta rockets in June and July of 2003. The rockets will provide the appropriate speed needed to get the spacecraft to go to Mars. The spacecraft consists of a cruise stage, which supply the communications and power during the 7th-month journey to Mars, and a lander, which has the rover inside it. Upon arrival at Mars in January 2004, the landers are separated and enter the Martian atmosphere.
Once the lander enters the Martian atmosphere, the aeroshell design will slow the entry from 12,000 miles per hour to about 900 miles per hour. A parachute will then deploy, further slowing the spacecraft. Then, airbags will inflate around the craft to cushion the landing. About 600 feet above the surface, retro rockets will fire, slowing the craft even further. Once the spacecraft stops rolling, the airbags will deflate and pedals will open up, bringing the lander to an upright position. Since the rovers carry all of their instruments on board, they'll be able to start exploring the planet almost immediately without having to stay close to the lander. How will the rovers be commanded? Will they be driven by remote control from Earth?
Actually, the controllers from the Earth will only command the rovers to specific soil and rock targets. It'll be up to the rovers to find their own way to get there. The reason we have to do this is because the signal from Earth takes too long to get to Mars to have us operate them by remote control. As a result, the rovers must be able to operate autonomously. We will decide based on the information we get from the cameras and instruments that are sitting on the rover where are good sites to go to, and then command the rovers to go there. We hope the rovers will be able to travel up to a half a mile from the landing site.
Okay, so once a rover gets to a rock of interest, how will it examine it?
The rovers have many different instruments on there that allow us to examine the rocks down to the microscopic level. Once we analyze this type of information, we can tell a lot of different things about the rock themselves, like their mineralogy, elemental chemistry, their surface texture. This type of information will give us evidence of ancient environmental conditions and the possibility of some type of biological activity occurring.
Recent satellite images of Mars show geologic features like channels, which support the theory that liquid water once flowed over the surface. Today, the Martian temperature is too low and the atmosphere too thin for liquid water to exist on the surface, but many scientists believe that liquid water may still exist below the surface of Mars, where temperatures are not as harsh. If the rovers find convincing evidence of liquid water on Mars, then it's also possible they may find proof of life on Mars as well.
There's a lot of evidence that there's frozen water just below the surface of Mars, and a lot of these missions that we're trying to go to Mars in the next few years is trying to get a better understanding of how much water is there, and is it in the liquid form near the surface somewhere. 3 billion years ago, Mars and Earth were very much alike. Mars was at that time much wetter and much warmer than it is now, and something has happened. So by trying to get a better understanding of how Mars's environment has evolved, it will give us a better understanding of potentially how the Earth's environment would evolve and give us an idea of how it's going to change in the future.
So by studying Mars, it may be able to tell where our future is headed on this planet?
Exactly. The reason we are exploring Mars, and other places in the solar system for that matter, is to help answer two fundamental questions. One, to explain the formation and evolution of our solar system and the Earth within it, and two, to seek the origins of life and its existence beyond the Earth.
During the next decade, Mars will be the solar system's most popular travel destination. There are plans for nearly a dozen Mars missions being planned by 3 countries, the United States, Russia, and Japan. Coming up, a new device developed by NASA might help parents and caregivers keep an electronic eye on their children. But first, did you know that the Viking 1 spacecraft was the first craft to land on the Martian surface on July 20th, 1976? With its companion craft, Viking 2, the two landers analyzed atmospheric and weather conditions, collected soil samples, and took over 56,000 pictures of the planet's surface.
Unfortunately, in recent years, there has been an alarming increase in deaths of infants and small children after being